geotechnical engineers. Yesterday, you did a test with models, and both your plastic containers represented the riverbanks, right? Your river goes right at the edge of your soil. So now, you've got trays in the back. You know exactly what type of soil that you need to do your test. I want to give you a lid.
Okay, what's going to be out more? That one is not 11, 12. Wow. 13, 14, 15, 16, 17, 18, 19. Almost there. 20. Stop. 20.
Why don't you put a lot of rocks by the pole in the rocky soil?
Now you can put that. 46. 48.
48.
We got 50.
Okay, I've kind of been wandering around, and it looks like everybody has done at least one test. Nod your head if you agree. Okay, I want to try to get our trays. We're going to have a little contest. Whose tray can get back to normal in an organized way so we can talk about it? In your journal, next step, last one for the day, we've got to think about some information that you just gathered, because you gathered a whole lot of information here. You're now going to give yourself a score. Your scoring sheet is in your packet, and there's a giant blown up one back here, all right? So the first score that you're going to get based on what you just did is a strength score. How much weight did your TarPul that your team created, how much weight did it hold? You know when you play baseball and kickball and football, do you want to get a lot of points or few points? You always want to get a lot. But in this game, a low score is a good thing. This is what your goal should be, to get a 1 or a 0, and that would be getting weights between 40 and 50. Did anybody get that? Between 40 and 50, how many?
Well, we went over that. We got 54.
So you're right here. You didn't get any points. Is that a good thing or a bad thing? A good thing. So give yourself, right now, record the weights and give yourself a weight score. Okay. All right, ready? A location score. Write down how far your site was from site D and give yourself a site score. Where do you find that? It's in your packet, or you can look back here. So give yourself a location score. All right. A compaction score. How much did you and your team compact, press down that soil? Think about side 1. How many inches? 0, a fourth or a half. Think about side 2. 0, fourth or half. Look up there on your compaction score sheet. If you did a half, you get 2. What if you did a half and a fourth? What would your score be? A 3. What if you didn't do any compaction on one side, but you did a half on the other? No compaction on one, but you did a half on the other. You get a 2. Give yourself a compaction score. And another factor we've really been focused on this week is that erosion and the importance of picking a site that's on a very straight part of the river. All right, look what you get, because you might have to do some subtracting here if you picked a straight part. How curved was the site that you selected? If you picked a very curved part, you're going to get 2 points. Okay? If you picked a slightly curved, you don't get any points. But if you picked a straight part, you get to subtract 2. That's going to lower your score even further. Give yourself an erosion score. Add all of them up and give yourself a total score. All right, give me a score with your fingers. Show me what it was, your total score. Look around the room. A 1, a 5, a 6, a 4, a 5, and a 4. Now, is this a competition against each other?
No.
No, it's a competition for tomorrow. What can your team do differently to improve your TarPul so that your score goes lower? That's what you need to be thinking about overnight tonight, okay? What's something your team could do differently tomorrow when you get to improve? I want you to have a table talk. What can you do different to get your score lower tomorrow? Go.
I think we should probably change it to effort E, not C.
Yeah, we could like E, and then we could pass it like 1/4, and so that would only have us 3 points.
So we would have
3 points. 3 points, but then if since it's straight, it was -2.
We'd have 1 point. Yep.
Are you all changing sites or keeping it?
We did Kristen's playing today. Tomorrow we're going to do mine.
Okay, that sounds. All right, engineers. Yes. Great discussions, all right? And there's a team in here that is still grappling with 3 of them want to do one site, another person wants to do a different site. And do you think that happens with engineers in the real world? Yes. Absolutely. Do you think they work their way through those issues? Absolutely. So tomorrow, and that team doesn't have to worry because they get to have more discussion tomorrow. Tomorrow you get to improve. So that means you might have changed some things. You might have changed your compaction. You might have completely changed the soil type that you're going to use tomorrow. You might have changed your location completely. All right, so tomorrow you'll fill out an improved plan, and then you'll do almost the exact same thing that you did today. You're going to create it, and you're going to test it again. All right? And then, okay. Yes, ma'am.
Well, I was just going to say that yesterday when I was on the bus, I saw some people downtown taking a core sample.
Oh yeah.
No way. Where downtown?
I don't know, but it was like on a corner. It was like on a corner, and I don't know where. I just saw it.
So tell us more. What did you observe?
I saw like soil coming out from the bottom, and really, it's all.
Okay, and then you drove on by?
Yeah.
That is so interesting. I don't even have to wake your brains up today, do I?
No.
All right. We have gone through all these steps as engineers. What have we done?
Ask, imagine, plan, create,
Improve. So in your journal today, this won't take you, I don't think, very long because you've already had a lot of really rich discussion. But you're going to talk about what your score was from yesterday. All right, just pop that right there. How are you going to try to improve that score? What changes are you going to make? All right, will all of teams 2, will their paper look the same?
Yes.
Because they have to agree. Will team 2's look identical to team 4? No.
It shouldn't be.
Okay. Any questions on your improve? And once I see your plan, you're free to get your materials and we'll get going, okay? Any questions? No.
I think we should still do site E because it's one side away from B and it's straight.
What are we doing?
Because that would already get us -2 because it's totally straight and it's one side.
Okay.
That would get us -1.
And we have to try to make it hold more weight.
Yeah.
All right, let's see what you got, guys.
Oh, I
You're
know.
changing everything. Wow.
Except the erosion score.
Okay.
Oh, Ellis, I know why. Miss Keelan.
You're compacting the organic, but you're not. Why are you choosing not to compact rocky, but you are organic?
Because Rocky's harder to.
Wait a minute, one at a time.
Because Rocky's harder to compact, and Rocky's already pretty strong.
Okay, and what was your reason?
Rocky soil is stronger than organic.
Okay. All right, you all ready to get going?
Yeah.
Okay.
Whoa! Ellis! You
side away, so that gives us 1 point.
Okay.
And then -4 gives us -1. And then we got 0 points there, and it matters how much weights we get.
Ah, that's the one undecided factor,
We
right?
just gotta get 40 or 50 or 0, and then we'll get either a 0 or a -1.
Oh, I'm crossing my fingers. Way to go, engineers.
Okay, I'll get the weight.
We were at side E, so we're going to side A.
Yeah, we're moving to side A because it's rocky soil, so we can get no compaction on that because rocks are stronger than just regular soil. Let's get it. 11, 12, 13, 20. Where's that? 20. Maybe we should try to improve. That's what I'm trying to.
Okay, we'll do 1/4 of compaction.
Let's do 1/4 of compaction.
Okay, I'll compact it.
Yeah, one.
So we gotta go to that middle line.
So we got 40 weights. 40 weights. You go to this one, so we get a. What did we get here? A 1. And then right here we are 1 side away.
I think we should compact the board. It's straight to red 0. Make sure that's
You to help me get more organized with data.
We had 48.
Whoa! I saw some major geotechnical engineers improvements. What team in here improved their score over yet? Every team, get out of town. We are dying to hear some of these results. I need to know what was your score yesterday, and we're really curious about how far down you moved your score. Team 6, score yesterday? 6. And drum roll. Today's score? 5. Say way to go, Team 6! Wow, a 1 point improvement in each team so far. Team 2, yesterday's score.
5. Yes.
Oh.
A 2.
Oh, come on, 2, 2, say way to go, Team 2! And I just have to know, how did you improve by 3 points? Kanye?
We kept trying, and we made it to 50.
Oh, you improved your strength score? What was it yesterday?
It was 2.
It was a 2. And then today?
It's a 0.
A 0. So that's how you gained 2 points. Do you remember how you gained that 1 extra point today?
From the soil compaction.
Ah, what'd you do yesterday?
We did 1/2 soil compaction.
Okay, and today?
1/4.
Ah, they gained a point for a total of 3. Way to go, Team 2. Team number 3. Yesterday's score?
4.
A 4. And today's score?
2.
A 2. Whoa. We all improved. Doesn't that feel good as an engineer?
Yes.
What step up there in the engineering design process was the most important to you this week? Austin?
Plan.
Plan. Why plan?
Because if you didn't have a plan, you wouldn't know what to do, and you couldn't create your thing and improve it because you had no clue what was your plan and what to do.
If you don't have a plan, you have no clue what you're going to do. Absolutely. Ethan, what's important to you?
Improve.
The improve part. Why?
Because if you create something and it's not good, it could collapse or something. And to improve, you would make it like not collapse as easily.
The cool thing is about engineering, you keep getting shot after shot of improving. So don't ever give up when something doesn't turn out right. And that goes for your schoolwork too. When you're studying for a test, the same thing applies. Okay? You might not do so well, but you're going to get another opportunity at it, right? To improve. So I think there's a lot to be learned from engineering and the way that you operate in your daily life, okay?